So this is question 1. Let's read through it. A tennis ball is hit with a racket from a point 15 meters above the floor. The ceiling is 8 meters above the floor. The initial velocity of the ball is 15 meters per second at 50 degrees above the horizontal. Assume that air resistance is negligible. So there's the diagram. And the question is, determine whether the ball will hit the ceiling. So we need to figure out how far the ball goes in a vertical direction. So this is obviously a SUVAT question. So I've written a SUVAT list for the vertical motion, and I'm just going to state that upwards is positive. So I need to calculate vertical displacement. And I need to know the initial velocity. Well, if we look at our diagram here, I can take that 15 meters per second vector and I can split it up into two components. So the horizontal component becomes 15 cos 50. The vertical component becomes 15 sine 50. So our initial velocity is 15 sine 50. Our final velocity vertically is 0 when it reaches its maximum height, and the acceleration is acceleration due to gravity minus 9.81. So then I look in my data booklet, I find the equation I need. I need one with velocity, initial and final velocity, acceleration and displacement. I rearrange it to make displacement the subject, put the numbers in, and I get an answer of 6.7 meters. Now, that's the height that it travels from the racket. So if I add another 1.5 meters on, because that's the height it started from, the total displacement in vertical direction is 8.2 meters. So it will reach the ceiling, it will touch the ceiling. The second part, the tennis ball was stationary before being hit. It has a mass of 5.8 times 10 to the minus 2 kilograms and was in contact with the racket for 23 milliseconds. Calculate the mean force exerted by the racket on the ball. So I look at this bit of data and I realise that that is mass, that is time, and I need to calculate force. And so I know also that the initial velocity was 15. So I look in my data booklet and I realise it's something to do with this equation, that force equals the change in momentum over time, or mass times change in velocity divided by time. So putting my numbers into the equation, I get an answer of 38 newtons. And the final bit of this question is explain how Newton's third law applies when the racket hits the tennis ball. So there are 2 marks here, and the first mark is for stating that the force of the racket on the ball is equal, and that's the key word, to the force of the ball on the racket. That would be 1 mark. And then saying something about direction. The force on the ball is in the opposite direction to the force on the racket. So that's explaining how Newton's law applies to this situation.